We are resuming lesson 2, and today we'll be looking at quadratic application quadratic function with table of values. So we've completed in the previous lesson application when the graph is given and when the equation is given. So with these two we've done. Today we're looking at the table of values is given. And the final part we look at verbal description. So in the previous ones you're given the graph and the equation using your graphing calculator to answer the questions. So let's look at the first example. Now, for these, you will still again need we'll definitely be using our graphing calculator today. And our Desmos. So we'll be using any one of these two today. So here's an example where an archway, kind of a picture of it here. You have an archway, and it has this values here. Archway is a parabolic shape. Here's a parabolic shape here. Some measurements taken from the archway, as shown in the table below, determine the quadratic regression equation. So now we need to find that equation. So here is for horizontal distance and our height. So what I like to do, generally speaking, is to give myself a sketch of what the graph will look like. So this will be a general sketch. We have a horizontal distance. And this is in feet. And we have our height. Let's tell us also in feet. Zero here. So we have our x. We're only dealing now with quadrant 1. Now notice my variables from 0 to 6. So I have 0, and I may have here 1, 2, 3, 4, 5, 6. I don't know my maximum height. Looks like it goes up to about 10 here. So I'll make that 12. So I know it will have a parabolic shape. But I need to find the equation. Okay. So let's build our calculator here. And it's been a while since you enter data. Right. So here's our data. We're given our data. We need to enter that into our calculator. So I'll zoom out here so you can see a bigger picture here. So now go back to our instruction sheet on your graphing calculator. How to enter data to the list. So we need to go to this page here, which is on calculating instructions, and I'll show you in Desmos in a minute. So we're going to clear our data first. We're going to clear our calculator. So I'm going to make sure it's reset. So I'll go to stat. So I'm going to follow the instructions here, and I'm going to reset number 7. Press enter, number 2 here, and that's all clear. Now we need to enter our data into our calculator. So we're going to follow a set of instruction here. So we're going to remember what you've done before, but just in case. So make sure you have this handy with you. to enter data in the list here. So I'm going to enter our information in the list here. Okay, so press our Stat button and press Enter. And now you should see L1 and L2. So now this becomes your L1 and L2 is your height. So on the L1, I'm going to enter my data, 0, enter. Then I press 2, enter. 8.59, enter. 9.38, enter. Now I go over, toggle over using my right arrow key here. Move it to L2, now 0. Oops, sorry, I made this mistake here. It should have been 4, enter, sorry for that, and 6. So there's my L1. I jumped too quickly here. So 0, 2, 4, and 6. Make sure you have those correctly down, or else now we have 0, and the next one is 8.59. Next is 9.38 and 2.34. Now I've entered my data into my calculus. So I make sure they're all right. 0, 0, 2, 859, 4, 938, and 6. And then put that here, enter, 234. You have to press enter to make sure it's included in the cell. Now, in the next step, you're going to turn the stat plot on. So, okay, it says stat plot on. So second, trace, and I press on. Now I need to change my window setting. Now go back to, remember what I did here? My sketch, my X minimum is 0, and my X maximum is 6. So I may increase this to 10, and my Y maximum minimum is 0, and my maximum is 12. So I'm working just for the quadrant 1. So I need to go to my window setting now. So window setting, I'll make that 0. Maximums. Now also Y minimum is 0. I'll increase that maybe to 15. Okay. Now if you were to press the graph, you'll see the points there. But there's no equation. Okay, right now you'll see this set of your data is all, but no equation. Now we need to determine the regression equation. That's what we want, because that's what they ask us to do. So you get a regression. Now, after you enter L1 and L2, which you did here on the stat button, that's right. Your stat plot is on. You change your window, right? Now we're going to get a regression equation. So press your stat button. By the way, this is in your previous booklet, unit 3. So we're going to, we press and choose the right arrow key to go to calc. So we need to go to calc. See my right arrow key to go to calc. And now they ask you now, I want to go to my now if I go to a linear regression, I'm getting a straight line, but now I need a quadratic. So now I'm dealing with quadratic. I'm not dealing with linear anymore. The previous booklet we were doing a straight line. Now we're doing quadratic. See that up or down. This one was straight line. We're going this way. So now we're dealing with a quadratic. So we're going to go down now. Instead of going linear regression 4, which we used earlier, we're going to go to number 5. Press enter. Then you continue again, right? Press an arrow key. and go to the store. So we go down here. When you get there, stop, because next you press the vars button and you go to Y vars. And then you press the enter 3 times. 1, 2, 3. And you can press 1 more time, and then that's your equation. And I said to make sure you write the equation. Now, let's interpret what that means. So the equation now, it's y equals, it says here now the ax squared. So we have, so a quadratic equation is y is equal to ax squared plus bx plus c, which we established at the beginning of this section. So the a is negative 9, negative 0.976, so we can make that rounded to 0.98. So negative 0.98 x squared. So wherever the a is, you replace it with negative with the a value. Plus, keep your x squared, your b, 6.25. X. And the c is negative 0.0015. Practically speaking, is 0. Okay? So we here plus 0. So that's our regression equation. Okay, now if you press graph now, we'll have our wonderful graph. So now I'll go ahead and do my sketch. So my sketch is, my calculator over here. Now, before I go ahead and sketch, I want to look at my parameters. My domain here, 1, 2, 3, 4, 5, 6 is between 6 and 7. And my height, now I will find my vertex, right? So let's my graph. Let's find my vertex first, right? So let's go to second trace. And we want a maximum height. So here our maximum height. So I need to find my vertex, which is your maximum. Okay, goes over here. There we go. So I need to find my maximum height. So I go down to maximum, and it says left bound. So I go to my left of the vertex. No, by the way, you can turn off your stat plots so you wouldn't see these points. But press enter. Now I say go to the right of the vertex. Press enter again. And there's your vertex. So 3.2, so around 3.2. So my vertex here is 3.210. So horizontal distance is 3.2, and your height is 10. Okay, we need to find out where it lands on the ground, right? So we need to find, now we need to go to find our intercepts. So I go to my Y button, and this is to find your x-intercepts. This is the instructions here. Enter your y1, which is enter y equals 0, and choose 5. So I'm going to put 0 in there. So the second trace, intersect. I want to find the first one. Let's find the second one since we're on the right side, doesn't matter. Press enter 3 times. So 6.4. So this is 6.4. And that should be 0. So second trace, intersect, go to my left side. Press enter 3 times. Oops. So now that's practically 0 is 0.00039 or 239. So it's 0, 0. And those are my parameters. Now I can ask my question. What is the maximum height of the archway? The maximum height is the vertex. So the vertex is 3.210. So the height, the y value, is the height. So maximum height is equal to 10 feet. The minimum height would be 0 down here. So 0 feet. How wide is the archway? Now the height, the width is the distance between the two intercepts. So the distance between two x-intercepts. So 0, 0, and 6.4, 0. So the width is 6.4 meters. Now, if you were to use Desmos, it would be a similar scenario now, but Desmos is slightly different. So we want to enter our data in Desmos. So I'll clear. Now, you can follow the instructions from display your data. So once we open up Desmos, first we want to hit the plus sign. So we tap the plus sign and we want to go to table. And now we can enter our table. This will be your X1, this is your Y1. So we'll enter 0, enter 2, 4, 6. Then go tap to my right now. I want to enter 0, 8.59, enter 9.38, and 6 is 2.34. So there are my points. Make sure they all run 2, 0, 2, 8.59, 4, 9.38, and 6, 2.38. So you can see the kind of a parabolic shape it's turning out to be. Now I need to put my equation in. And now this is a different equation. Now the previous one, once you have your data, back here. So we enter the data into Desmos, but now we will use a different equation. The previous one, we have this y1 tilde mx1 plus b. Now for your quadratic function, and you probably want to write this down. Okay. So we're going to enter that into our new line. So we've done that part now. So we put that here. So you move this up a little bit here because our table will go down to cell 2. Tap that. And you're going to enter Y1. So you're going to do Y1. So there's Y1. So remember that it's your Y and the 1. Now we need this tilde, kind of a. Now you have to hit the ABC pad, and that will give us our letter or keypad. And the tilde is right to the bottom right-hand corner here. Tilde. And now we'll put exactly what we see here now. So A, X, and I have to go back to my number pad and put 1. So it automatically gives you the 1, but I need to put my square also there. But remember, in this case here, we have a negative. This graph is going down, so we need to have a negative line of best fit. So in this case here, y1 tilde negative ax squared 1 plus bx plus c. Okay, so we're going to change that. So we have negative a x 1 squared plus bx plus c. So we need to get that. So we need x. Then put my 1 there. There we go. And plus c. So it's negative ax squared plus bx 1. Forget to put 1 there. Plus c. And now I have my graph. Tap there gives me my maximum. Tap there gives my intercepts, which is the same as we have here. So 3.20, we have 0, 0, and 6.4. So let's remember, just you need to record this down here, which is the same as what I have here. So if it's a graph going down, it's a negative. Graph is going up, would be positive. So this would be a graph going down, and this would be a graph going up. Okay, so that's one. Let's go on to second part here. Well, the table of values here is given. So we're gonna, a ball was thrown into the air and the pad generated the following data. So now I'll use Desmos for this one here. So I'll keep my equation here, but I'm going to change my set of data now. So I'm going to hit my tab button, table. Oh no, I want my first one. Okay, we have to clear everything here. Okay, so tab plus table, x1. So now this will be x1, and there's moves on x2, y1. So x1, y1. So in x1 we have 0, my number pad, 0 enter, 0.25 enter, 0.5, 0.75 enter, 1, 1.25, 1.5, and 1.75. Okay. So we have here 1, 9, 11. If decimals recognizes there is a sequence, it will automatically enter the value. That's what we had over here. It's going up by increment of 0.25. So it just automatically entered this for you. In this case, there's no pattern here, so it doesn't recognize it yet. 13, 0.75, you have 12, 11, 7, oops, and 0.5. Nope. Then this one here, 1.5 is 7. Okay. It's going to give us 0.5. So there are our values. Make sure I got these all right. We have 0, 1, 0.259, 0.5, 11, 0.75, 13, 1, 12, 1.25, 11, 1.57, and 1.75, 0.5. Now, I want to go to my next line 2, and I'll enter. Anytime a ball is thrown in the air, we have a negative quadratic. So now we're going to go into this equation into it. So I have my y, 1. Make sure I put that 1 there. I'm just going to highlight this here. And this is your straight line. So if y1 and you go tilde, we have negative. Back to a x1 squared plus b x1 plus c. And there is our graph. Now I can tap here, give me my, oops. That's my vertex. I just want to behave. Okay, we'll do it again. Okay, they are my points, my critical points. Now they ask you to determine the regression, the quadratic regression. Now, and here where you get your quadratic regression. Okay, I'll zoom in here. So here we have a, so negative 15.66. your B is 26.7, and your C is 1.8125. So my equation now becomes Y. Okay, let's zoom out here. So this is your regression equation. So equals negative A is 15.67 x squared. Now plus 26. Now B is 26.7. And you keep your x. And the C is 1.8. So that's your regression equation. $15.67, and you get that from looking at below it. Now, we don't need R square. It's not for our purpose right now. We just need the regression equation. Next, the maximum height the ball reaches, which now we're going to find the vertex. The vertex, go back here. No. The vertex is 0.85, 13.2, so 0.85. So that's your seconds when it's at a height of 13.2 meters. So the maximum height is equal to 13.2 approximately meters. Now the next question, how high will the ball be after 6 seconds? So this is our time. We want to know at the time when it's 6 seconds, or 0.6 of a second. 0.6 of a second, what is the height of the ball? So what we'll do, we'll enter another equation. So there, x is equal to 0.6. You want to find y. What is y? So if we know x, so we'll have our x equal to that value, which would be a straight line here, and where it intersects the line will be the height. So we got to go back to a different line, a line 3. And I'll put here x equal 0.6. And that's this line represents 0.6 of a second. And where it intersects, by tapping here, at 12.2 meters. That's the height. So y is 12.2 meters. So at a height of 12.2 meters, or 21 meters, would that be? Yeah, maybe with 21 meters, 2 decimal places. Now, how long will it take until the ball hits the ground at the end of the arrow? Now, we need to find out the time the ball hits the ground and where it lands. So we need to find our. Notice this ball didn't start from the ground. Actually, the person was above, right? Ball swing near. So this person was was way up here. Okay, so we need to find. So at 1.8 meters above ground, this person threw this ball. Okay. So basically, we want to find, because the person threw the ball when time was at 0, 0 here, this point here. We need to find now the x-intercept on the other side. Because the ball is in the air from time 0 to when it hits the ground. So when it hits the ground, it'll be 1.77 or 1.78 meters. So it take 1.77 meters. Sorry, seconds. This would be seconds. So that's how long it takes. So you need to find the intercepts. We know the ball is thrown at time 0 and hit the ground at 1.7 seconds. So it asks you how long does it take before the ball reaches a height of 5 meters. So now we do the reverse now. Okay, go back to my graph here. So at 5 meters for the first time now, let me just clear my graph here. Get rid of that. Notice at a height of 5 meters now, where is the time at this point here at 5 meters? So if I were to draw a line through here, it says, how long does it take for the ball to reach a height of 5 meters for the first time? Now there are 2 times it will reach a height of this point, one here and for a second, when it's going up and when it's coming down. So now we're going to make y 5 and find for x. So y is equal to 5. What is x? We need to find x. So in our calculator, we'll go up to a different line here, line 3, and we let y equals 5. And there's our line here. It's going to be here. So when it intersects at 0.13 seconds, this is the height. So x is 0.13 seconds. Now the second time it'll hit when it's falling down, it's at 1.5 seconds, same height at 5. So if I'll do a sketch of my graph, it will look something like this here, then back here, and 1.77. And we know there's going to be 13.2. Now, if you use your graphing calculator, it will be will change. Clear. You just clear. You can reset our calculator. We enter our data into our calculator. And you press your Start button, enter, and to clear. Now you can re-enter the data there, but what you may want to do, go to second and reset your calculator. And follow the steps again. You go Stat, Edit. Now it's all clear. We have 0.25, 0.5, 0.75. Enter 1, 1.25, 1.5, and 1.75. Then go over to the right. We have 1, 9, 11, 13, 12, 11, 7, and 0.5. Now we have all of our data. We go to our stat plot, make sure it's on, turn it on, enter. Then we go to our window. We're dealing now, look at our window here, right? Our time is less than 1.7. So we'll make that 0 to maybe 4. Let's go at 4 seconds. And our minimum is 0 to a maximum of, here's 13. Let's make that 20. Graph. Now, this data look kind of suspicious here. What we have here, I'll go back to my Stat button. It isn't wrong. Is 0, 1, 0.259. Now here we go. That should be 11. If ever you see something suspicious, it means that your data is off. 1.2511 now, okay? That should be fine. Now it's a better graph. So there are times when you look at your data and it looks suspicious, go back to your stat and you are entered it wrong. Now, go back. Now, once I have my graph, I go to my stat button, go to calc. Now I need to go get a quadratic because I'm doing quadratics. Number 5, press enter. And I go down here. Then I press my bars button, put a Y bars, press enter. And there's my equation, negative 15.67 plus 26.7x plus 1.81. Graph. I want to find my vertex, second trace, maximum in this case. Move to my left. Okay, second trace, maximum. Left bound. Okay, now it's way below. I'm looking at my data here. It tells me negative 22. So I need to go up. Press my left arrow key. I need to go to my left. So if you don't see your cursor, look at your data here. Here it tells me it was negative, y is negative, but I need to be above in positive range. So now I have that, press enter. Then it tells me right bound. Press enter 2 more times. And it's 0.85, 13.31, which is what we have here. Now to find your intercept, you let y be 0, 2, this graph, and now you're going to find your intersecting points. So second trace, intersect. So 1.77, which we got here. And the other one, so that's all we need for this. They ask you now, how long does it take the ball hits the ground? So we know 1 point. How long does it take before the ball reaches the height of 5 meters? Now, when h is, now in this case, your y is 5. So we're going to remove our y equals 0 here. Clear that. And we go y2 and equal to 5. So your y now is 5. And you'll have a line going through y equals 5. So we want to find where it intersects y equals 5. Notice I remove my y equals 0 and my graph, the second trace, intersect. On my first intersect, now I'm still with negative, so I'm going to go back up. And I go over to the left side, close there, and I press enter 3 times. So 1.13. So here we have 0.13 seconds. So that's using our graphing calculator to derive the quadratic regression when you're given a table of values. You'll want to try question 4 in your booklet on assignment 2. And also question 5, assignment 2 in your booklet. The next lesson, we will look at quadratic applications with verbal description given.